All right, so following on that question that came up in the last discussion is, why don't we have vaccines for everything? The immune system we've talked about is this wonderful system, and it's an amazing mechanism for fighting off all manner of infection. Why can't we simply use the immune system through vaccination to try and treat all manner of diseases? So malaria, cancers, bacterial diseases. What are the challenges inherent in some of these, in developing vaccines for these other maladies? Mary, you cut you off on the last one.
In the middle of a statement, I think the best place to start is to see if there are people who actually have protective immunity, and then we simply copy it, or now copying means that we have ways to induce it. But if we don't have that first example, then it becomes quite a bit more challenging, and HIV, I think, is a very good example of that.
So the difficulty with HIV is not the localization of the virus, is it? Or it's just that it's difficult for a human to mount an immune response against it? Isn't there a localization issue with HIV?
I'm not sure what you mean by localization.
Doesn't the virus, I think it's a retrotransposon, does it get into...
No, it's a retrovirus.
Okay. Yeah, maybe you're better to tell me. Doesn't it in some way get in and hides away from drugs in some way? It's under the radar.
It can do that, so that it may infect a cell and then not replicate.
Okay.
Of course, if it's not replicating, it's probably not having any adverse effects as well. But even in individuals where it does replicate, there are antibodies responses and cellular responses to the virus, but they're not always protective. Okay. And so what do you induce? Then we can make antibodies, we can induce antibodies to HIV, but if they don't prevent or they don't alter the course of the disease, then it's not an efficacious vaccine.
But I think your first point is really important, that it's true, I think, that all of the bad diseases we have good vaccines for, nature does well. So have we ever made a vaccine that does better than natural immunity?
Well, some of the bacterial vaccines do at least extend immunity beyond what natural immunity would be, right? And so I'm thinking like the recent large-scale experiment with the conjugate meningitis vaccine in sub-Saharan Africa, where classically it had been a polysaccharide vaccine based on a sugar on the outside of this bacterium that provided a year or two's worth of immunity at maximum. Right. Now that's been conjugated to a virus, and I can't remember which virus it is, but it's been now conjugated to a virus and produced a vaccine that is hopefully going to produce upwards of 10 years of immunity. And in the rollout across the meningitis belt in sub-Saharan Africa, there's actually been a dramatic decline in meningitis disease as a consequence of this, right? Yeah. So you've had some experience in developing vaccines for bacteria, is that right?
Certainly, yes, and so I concur. I think that's one good example. So addressing your question out there, so I think it's an important question to consider from two different perspectives. So one is really from the clinical perspective, or just a pretty pragmatic perspective. So when you're looking at whether or not you can improve upon nature in terms of a natural immune response and protection, vaccines certainly do a much better job, in fact, in the face of a variety of different insults, if you will. So, for example, you have to have an active infection and then be protected. That protection may not last as long as Matt just suggested. So with a second booster immunization, you actually might extend that span significantly more than natural infection might. I think from a more pragmatic standpoint, vaccines do enable you to focus the immune response not to a variety of other antigens that a pathogen might present. And this is particularly true for either recombinant or otherwise modified vaccines. And a vast majority of vaccines are somehow or the other processed, so you're actually channeling the immune response to things that are hopefully going to be beneficial. So yes, in a sense that they do improve upon the immune response. Unfortunately, we've not been able to come around from that issue about can we improve upon nature itself at telling us which vaccine is likely to be successful based on what happens naturally. There have been some improvements, but not dramatic ones.
I think that with the new technologies, there are some hopes that we might. I think you're right that historically we've never been able to do much better than nature. But I think with the new technologies, there's some interesting promises, because I know with a lot of a lot of the infections that are difficult to vaccinate against is because you got a lot of immune escape. So you got a evolution of antigenic drift or something. That's the classic challenge with influenza, for example, where the virus changed from year to year, so the vaccine has got very low efficacy from year to year. But I think with the new technologies, so the problem with unnatural immunity is that it's just against the surface proteins of the virus, and there are new vaccines now that are vectored vaccines that uses other kind of adenoviruses engineered to express some of the other matrix proteins of the influenza, and they don't evolve very often, and so at least I think there's been experiments in mice where you can get much stronger and subtype transcending immunity through these clever new gene technologies. So.
It's actually an interesting point. Is it a better thing to target the immune response to one protective epitope, one protein, or to encourage a more diverse response? And what we've just talked about suggests it may not be best to just target. Yes. Although in the short term, if you know that you can prevent a virus from getting into a cell, I'm using viruses here, but any organism from entering a cell, an intercellular bacterium, for example, then if there's one epitope, it makes sense to block that, and then you don't have infection, and if you don't have infection, you're unlikely to have disease. But that seems like it's also a really strong selective force for.
Yeah, and that's the thing about something like malaria, the big protozoan genome. I mean, it's got lots of redundancies in those invasion pathways, so you lose track of how many different proteins and binding arrangements go on in terms of evading the red cell. So you could knock out 10 and you'd still have a bunch more. That's of course because natural selection has generated that. You know, natural immunity in people has been trying to block malaria for eons, and the parasite's really good at getting around that. And like you say, the antigenic variation as well, and the change through time.
Yes.
So we're always hearing that there's going to be a new vaccine against malaria.
Yes.
Is this possible? Or
ever since I've been in this business, which is somewhere in the mid-80s, it's been 10 years out.
Since you were in your mid-80s.
And it's still 10 years out. There is a vaccine that's been a very large-scale trial now that is getting efficacy in Africa. But it's not that great. It takes a third as long again to get malaria. So everybody gets malaria. The vaccine just delays the time until you get it.
And don't we drop the bar as well? We
keep talking ourselves down.
Yeah. And what is the effect of dropping that bar from, say, 90% efficacy, which seems to be a gold standard, down to something like 50% we'll accept? What's the problem?
Yeah, I think one of the problems is that the next vaccine, if you roll out something that's 30% efficacious, your next vaccine has to be quite a bit better than that to make it worth rolling it out. So you actually set up a huge grey zone where you rule out vaccines that are, quite a bit better.
Sure.
So the next jump from 30% might have to be to 80%. Can we do that?
Okay.
That's tough.
It's really tough, and so there might be an argument that we shouldn't put up with 30%. We should wait until we got higher to roll it out.
Yes.
On the other hand, I don't know, if I'm in the tropics for a bit and I've got to reduces my chance of getting malaria by a third, that's not too bad. I'd probably pay for that.